Even though humans created AI, we don't fully understand how it thinks. But don't worry, AI is not some sentient monster, it's actually just a lot of math. Machine learning is obviously very complicated, so I'll just explain one major part of it: gradient descent. Alright, buckle up because it's going to be a lot. At the heart of a typical AI model is a neural network, which is like a wired circuit that is trained to do a certain task, such as diagnosing a disease. Training the network is basically tweaking variables, which are like knobs on a machine that control the circuit's connections. So there must be some magic setting, some value for each variable that makes the network do what we want. But how do we find it? Imagine a machine that rates our network based on its errors compared to the examples. This is essentially the loss function, which takes in our variables and outputs a score. High is bad and low is good, like in golf. This graph would technically require one dimension for each variable, but we can't visualize that. The lowest point's coordinates is the magic setting where our network has a low score and therefore the least error. We can find it by using gradient descent, which is like descending a hill by walking down the direction with the steepest descent. To descend the loss function, we need to know the slope at every point. Thankfully, a function exists that tells us just that, and it's called the gradient. To take a step down the function, we subtract it from our current variables to get new variables that will result in a lower score. Large steps might overshoot the lowest point, so let's multiply the gradient by a small constant, such as 0.01, that ensures we take small steps. After enough steps, we will usually find the bottom of the loss function, and therefore, that magic setting where our network has the least error and does what we want. We usually don't know what the variables mean, but if it works, it works. Gradient descent can be used to optimize billions of variables simultaneously, which allows for complex tasks, such as matching DNA, detecting fraud, or researching ways to fight climate change. The increased use of gradient descent in the late 20th century was a major breakthrough for the world of AI. It's exciting to think about how AI will improve our world in the near future.